Last month, NASA's Perseverance rover successfully landed on Mars, with the goal of searching for signs of ancient life. Perseverance will remain on Mars for the next 600 or so days, collecting data about the planet's climate and geology. The Mars 2020 mission is also a critical step towards human exploration of the planet. This mission was 8 years in the making, requiring the hard work and dedication of scientists, engineers, technologists, and many others. I had the opportunity to discuss IT's important role in a successful landing with Jim Rinaldi, the former CIO at NASA's Jet Propulsion Laboratory and its current Chief Information Technology Advisor. Stick around. Hi everyone, welcome back to Today in Tech. I'm Julia Beauchamp and I'm here, as I mentioned, with Jim Rinaldi, the former CIO and current Chief Information Technology Advisor at the Jet Propulsion Laboratory. So Jim, thank you so much for calling in and joining us today.
Thank you, Juliet. It's great to be here and I look forward to the discussion.
Absolutely. I think it's going to be really interesting. So right off the bat, the sort of burning question in my mind, and I'm sure in our audience mind, is how does IT work to facilitate mission goals, especially as it relates to, the mission at the forefront of everyone's mind, Mars 2020 and the Perseverance rover landing?
Well, as your audience may or may not know, the missions take quite a while to be planned and put together. If you take Perseverance, the spacecraft that took it there, it took 8 years to create that mission. It inherited a lot from the Mars Science Laboratory, MSL, with the Curiosity rover to help speed it up. And in that time, though, technology decisions made 8 years ago certainly seemed like a long time in terms of technology. But in reality, what we do is to support a mission. It really starts at the beginning and how you start a mission, whether it's at the concept level, at design level, construction, and then into operations. In our case, Perseverance just landed, which meant that it's in operations mode now. And if it goes beyond its 2-year horizon, it'll be in extended operations if it's funded to do so. So the IT to support that is an evolution as well, because you have IT that supports all aspects of data collection, of how to access that data. Obviously, the cybersecurity is important. And of course, the infrastructure services all around the mission is an important part of it as well. And that goes not into just data centers. It also goes into clean rooms. It goes into where the construction happens. So it's a pretty, I would say, it's a little bit of everywhere when it comes to supporting a mission, and certainly something like Perseverance to support its goals, and where it's at now. So with that said, though, there's the IT organization has to be try to be the consulting organization. And that's what we turned ourselves into, a consulting organization. We certainly have the operational day-to-day type of roles to play. But as an operational unit, we're there, and a consulting unit, we're there to work on unique problems where we can help, whether that's in development, systems engineering, whether that's tools, or whether that's, in our case, we invested a lot in cloud computing and our own expertise, so that we could be expert consultants to our mission folks, and so that they did not have to learn all the technical that they may have had to learn in many years ago.
Absolutely. So it seems like IT played a really important role in supporting everyone on the mission side. So you've got the IT handled, you've got the technology for JPL handled, and they can focus on landing a rover on Mars. So I'm curious, you've mentioned that for this specific mission, you inherited, and the mission folks inherited, some technology from previous missions. Obviously, if this was 8 years in the making, I have to imagine that the infrastructure technology really evolved and changed over time. So I'm curious, how did it evolve and how did IT adapt?
Well, first of all, from the mission side, it just made good sense to use a lot of the infrastructure from MSL onto what they want to develop for Perseverance. In doing so, that meant the library systems, the systems that supported MSL, could be easily copied in a sense to support, the creation of Perseverance. So those kind of libraries, it's kind of rudimentary, but those libraries, access to those libraries, making sure that the mission development folks are have the security as well as have access is an important thing, and know where the data is. Now, it's kind of fundamental, but in reality, the technology we had to take advantage of was not only the current technology, but look at emerging technologies and how can our missions take advantage of those over time. And so if you take cloud, and I know it seems like everybody's in cloud now, but back 2012, 2013 era when Perseverance mission started, we were still learning the cloud. We had been early adopters, and we tried multiple clouds, and we still do. But we were learning how to manage in a cloud, how to operate ourselves in the cloud, and build that expertise. So over time, we invested more in that, and that certainly has paid off. We have that flexibility has benefited our missions as well as benefited operations and things of that nature. But also, we learned that the network had to be more robust because you're going to process more, you're going to have more data, and you need a very, very resilient network. So one thing we did is we made any network we put to the cloud a part of our network. In other words, it looked like that cloud was a data center in effect on our own network. And that really took some forethought. Now, people don't think about that. Mission people don't even think about that. This is something we do because we know that will provide a better experience for the missions.
I'm curious about some, specific examples of how your work adopting the cloud, for example, like you've been discussing, like really tactfully and really helped the mission folks. Are there any specific examples that you can point to say, our early adoption in the cloud here really benefited the mission in this particular circumstance?
Well, even prior to Curiosity, we had been playing with the cloud to speed up current processes. So, for example, we would get images from Mars from Spirit and Opportunity, which were two rovers prior to Curiosity. And those images used to take something on the order of 20 plus hours to process.
Oh, wow.
By allowing our engineers, now these were engineers that would normally do this on-premise computers, they worked with us to use the cloud, and they were able to cut it down to less than 2 hours. And so that meant the scientists could get the images quicker, make decisions about where the rover should go next and things of that nature, and what discoveries they may find in a little bit more timely manner. So that then led us into working with our mission engineers and flight ops people to work with more applications. So this is kind of building trust, building capability, and building expertise, quite frankly, so that the missions could take advantage of technology like that to either speed up operations, speed up processing, take telemetry data that comes from the spacecraft to talk about the health of the spacecraft. We put in systems working with flight engineers. We develop capabilities where that telemetry data could be processed in ways it could not be processed before. We could tie images of the day to that telemetry data of the day. We could tie all kinds of different telemetry data and then save that data for future use. And that's what we've done, such that could be looked at for things today. You might look at AI or ML to help process that data to say, what did you learn from that mission at that time? So we put a little bit of foresight in our thinking, but certainly had to collaborate with the mission personnel, and because they really guided us as to what they really needed, we could then provide the capability. And when you think about it, as an old software developer myself, having unlimited capacity, unlimited access to storage and networking, that's kind of a dream for anybody who deals with computers. And to be able to provide that kind of capability was something that we felt was important for our missions. Now, keep in mind, today, JPL has 18 missions in flight. So it's not just one mission as
Right.
important as Perseverance is.
Of course.
And plus we have 7 to 10 instruments in use on other spacecraft. And so our portfolio of technology and science and missions is quite large. And so IT has to look at where it can leverage across all of those, which we do a pretty good job of. And the fact that we can provide common set of tools, whether it's engineering, all the way to better search algorithms, better database technologies, and hopefully a better experience for our engineers. Now, JPL is a very smart workforce, and they have a way of staying ahead of us too. And so IT has to stay current and has to make sure that we're working to look at all emerging technologies. And we have some more examples that we'll get into a little later, that how we support through the different phases of a mission, how we support those missions and what technologies we use.
Yeah, so it seems like the mission personnel have a goal and IT has the software knowledge, they understand how the tech works, and there's a really important, marriage of ideas that's happening there to make sure that you can really support the mission folks so they are able to do something as obviously incredible as landing on Mars or accomplishing, of course, any other JPL mission.
Well, that's true, and it's really important for us to. This is one of those things where IT really has to listen well and has to participate well
Right.
and be a good partner, not being a controlling mechanism. That opens up all kinds of avenues of innovation and capability that we can share with the mission. They can decide how much they want to use. And that certainly happened with cloud, but it also happened with things like 3D printing. We were early adopters of 3D printing. And what I mean by that was technology at a cheaper level. When 3D printing was taking off, it was used to create fun toys and images and things of that nature. We brought in the capability so especially mechanical engineers, could print their parts of a rover. So if the arm of a rover could be printed 3D, where they get a better experience playing with it versus a 3D rendition on a computer CAD machine.
Right.
So we found a lot of value in that. And there was one, I can't remember the year, but we were doing a tour of JPL, and I was blown away by all the 3D printed devices I saw throughout the engineering building as we were going through it. And I knew we had an impact by doing that. IT actually even bought 3D printers and hand them out to engineers so that they could tell us what the value is to them. And it certainly showed off in that way. But that's just one example, certainly that we had to apply back then. And it's exciting, though, for the IT organization to be able to be the people to come to ask about IT versus being the people who have to respond to a very smart engineer who's gone out and found his own IT, which happens. It still happens today.
Of
But
course.
it's just the environment we work in. And if you can find that good mix, then you can have success on all fronts, in my opinion.
Yeah. That's a great example. I would imagine that having something as tactile as a 3D printed mechanical arm, for example, is going to be a lot more helpful to an engineer than something on a computer, and also way cheaper than, building the actual arm. So there's obviously an important business case there as well. I'm curious
Absolutely.
about some of the specifics around Perseverance. It seems like a general theme in your IT organization and in JPL's IT organization is learning from previous missions. And I'm wondering if there's any other specifics that you can draw upon that IT learned from Curiosity, for example, and applied to Perseverance, and what lessons and what technologies carried over.
Well, it's very interesting. Mars Science Laboratory, MSL, was the first mission that had more of IT support than any other prior mission.
Wow.
And so we had built the trust. Actually, one of the lead scientists and project managers back then is now the director of the lab. And he supported us, and he took a risk in supporting IT to be much more involved in mission operations That includes a mission network that includes front, from beginning to end on Curiosity. So we learned a lot during that. We certainly understood the goals of the mission, and they held us to those goals in terms of storage. So they used our services. Is what I'm trying to say is that, and so we learned what type of services they really need while they were using our services. That prepared us really well for future missions, including Mars Insight, which landed a few years ago, which also included Perseverance now that just landed a month ago. So we're very excited that we were able to learn from that and be able to be trusted to do the work we did. Missions were not, they were kind of siloed and prior work prior to that time, that they would get their own technology. They would get their own set of computers and servers.
Oh, wow.
They would, in some case, way prior, they would set up their own networks. Now we changed all of that, and then we made it much more economically feasible to utilize common, I'm going to say, institutional services to provide the support that they needed. That again played a long ways into providing Perseverance with a more normalized, trusted set of operations, and that includes networking. That includes outreach too, by the way. Curiosity was the first one that we put as much outreach material in the cloud than any other mission. And matter of fact, it was so popular the night of the landing that the internet traffic was greater than the closing ceremony of the Olympics.
Oh, wow.
So it was quite an event, obviously. And Perseverance then got to leverage that outreach. Outreach is a very important part of what we do at JPL, because it's not just, you want to certainly do the mission, but you also want to explain why we're doing the mission, and you want people to be engaged. And so we learned a lot, and we gained worldwide attention by having the right kind of capabilities that were in a cloud environment versus our own servers for outreach and web presence. And that was a very successful, and we've been able to do it for Perseverance going forward. Early on, though, it really takes the cooperation with mission people to build trust. I know in earlier missions, I invested for a person who wanted a 4K camera. He could not afford a 4K camera, but I thought it was worth having a 4K camera for what he wanted to do in a drop test. And so we bought a 4K camera for him. I funded it for him. That's the kind of collaboration and the risk that you take, but it paid off because now we know how to do 4K. Pretty soon we'll know how to do 8K, and you get the better experience, you get more accurate data, and you get the visual that really proves the case. I could go on because we've done so many things, and it's quite amazing the involvement we have, whether it's in supercomputers, whether it's in some of the software collaboration tools for that matter. And so I can go on about this. It's to me, I get very excited because the success of the mission is the foremost thing of the reason we're there.
Of course, right.
And so having the ability to do that and be a part of that, and know that sometimes we're in the background, which is okay, but we're providing that support that the mission then can leverage and have success.
I guess to stray from the IT side for just a moment, I'm curious about if your knowledge about any of the tech that's on board Perseverance and how it's different from rovers prior.
So if you were able to see some of the photographs of Perseverance, you notice that it took some selfie photos. One of the landers took a picture of the rover itself being lowered. We'd never done that before. And so what they did is they put 5 more cameras on the lander than we had before. So they learned how to do that. But also they put the technology on as it's landing, that it takes images of where it's at, and it uses those images to make sure that it's more precise in its landing, and that seemed to work. So that technology had some AI built into it with image processing built into it. Further, though, there's some exciting things coming that I was privileged to see the test of the helicopter. Now, the helicopter is going to unlodge itself from the rover, and it's going to fly. I think it's 4 or 5 trips, if I recall, and it will, or 10 trips, and it's going to fly around Mars. It can't go too far, but it's going to fly around Mars, and it's going to take pictures and send them back to the rover, and the rover will send them back to Earth. So that's going to be that's never been done before. And so that's going to be very exciting to see, those kind of pictures, almost like a drone, if you will,
Yeah.
taking pictures and sending it back. And then two other things I'm pretty excited about. It's just an exciting mission to begin
Of
with.
course.
There's an instrument called MOXIE that is going to take Mars atmosphere and produce oxygen. And if you can understand the rationale for that, is if we can learn how to do that really well, that'll support astronauts in the future.
Right.
When they go to Mars, they need to have the capability to generate oxygen. So we hope that goes successful. And then finally, one thing that is extremely successful that leads us into a future mission is Perseverance is going to take samples of the terrain that it runs over in various spots, and I forgot the exact number, somewhere in the 40s. And then we'll have a mission called Mars Sample Return that will go to Mars, land on Mars, pick up the samples and bring them back, launch from Mars and bring them back to Earth. And I can't, be honest with you, think of a more exciting mission than that.
Absolutely. I'm sure IT is already planning for it and helping to support it, right?
Well, the IT organization has done a great job of looking at what all these requirements are, especially data, especially operations, especially networks. And I think they're well prepared to support future missions as they come up. And we haven't talked a lot about cybersecurity, but that almost goes without saying, but it does deserve some credit in the fact that we have to really pay attention. We have to be vigilant all the time, and we have to be proactive. And the cyber team does a really good job of that.
And I think that really ties in nicely to my next question, because I think cybersecurity is obviously always going to be of utmost importance to any IT organization, but I imagine it was especially front of mind once everyone was required to work from home. How did the coronavirus pandemic affect IT's responsibilities when it came to supporting the Perseverance mission and other missions?
Well, I got to be a customer of IT at that point, and when we did, but we were prepared for disasters. We weren't necessarily thinking of pandemic. We were thinking more like, earthquake and stuff like that.
Hurricane.
Normal disasters. Yeah. Well, not in Southern Cal, but
fair enough.
Certainly, we do get our threats of weather as well. But we really put in the technologies so that we had a lab working from home before. In 2009, we had a fire that came very close to JPL. There's an amazing video on YouTube about that, especially with the night view. It looks unbelievable. But we had to prepare for those kind of things. As beautiful as Southern California is, it also has its little issues. Not necessarily thinking of a pandemic. Now, obviously the pandemic comes around and the IT organization does a fantastic job. It's under new leadership, a wonderful person, and they're doing a great job of making sure that we all can get in, work seamlessly from home, have the tools, have security, have the technologies we need, and the ability to deploy newer technologies in various ways to our employees, and they've done a great job doing that.
I'm curious too, just to touch on just for a bit before we wrap up, but obviously the mission personnel, when the rover actually landed, I was watching the live stream. You can obviously see that mission personnel were all together. They were in an office, as it were, but in a control room, perhaps, is the better term. Room. Yeah. But these people weren't working from home. So how does IT adapt to support remote employees, continue to support in-person employees, especially when they're working on something that is as literally mission critical as a Mars landing.
So when you have that kind of event, you have all essential personnel come in, and the lab had prepared really well for that.
Sure.
That included COVID testing on a frequent basis, making sure that only essential people came in. There were, what you saw in the control room were very important, but there were 1,000 other people supporting the mission,
Right.
Either in other rooms or in at home. And so the technology was certainly very important that it stayed up, it stayed accessible, and those kind of things. So I think it adopted really well to an environment that we weren't probably 2 years ago planning on, or a year ago, quite frankly, planning on.
Yeah.
And normally we would have everybody on board and everybody on lab, and in Caltech for hosting residents and things of that nature to watch and experience the event with us. And so this was a little bit of different, much more challenging. Certainly, there were not quite as many folks as they normally would be on lab, but the control room itself was already wired and geared up. All the computers were working, all the checks that go into making sure that's there, that they're secure, and that people can utilize them effectively were in place. And so you first want everybody to be in place. There's a lot of activity that goes on in those control rooms and beyond to make sure everything is checking out the way it can. What's interesting is there's an 11-minute gap in communications between the planet and between the Perseverance and Earth.
Okay.
And so whatever commands we were issuing or whatever things that we wanted to check on, we knew it already happened.
Right.
But you still have to do it, and
Yeah.
you still have to do the due diligence. So it could be a very tense moment when you think about it as it's coming in. That first
Absolutely.
heartbeat, when they first got a heartbeat, and that's just a little ping, they knew that things were moving in the right direction, and it's pretty exciting. I too was watching it just like you were, and with a few tears in my eyes when it landed, because it's such a special moment. It was really, from a personal standpoint, it was really special to be a part of that for as long as I was, and to watch the team that I know about and see be successful was also a very special moment in my career.
Of course. So, looking forward, I'm wondering what emerging technologies are on the horizon that you can see JPL utilizing for future missions, and what lessons IT has learned from this mission or any other recent missions that can be applied to future missions.
Well, that's a really good topic, and that's germane to what I'm doing today. So we are looking at a data strategy and data architecture that's encompassing beyond just a siloed mission, going across all areas of data at the laboratory, so that we can utilize the tools to better mine that data, to better get analytics of that data. So that's undergoing. We're doing something that's run by my former deputy, I'm very proud of, our Enterprise 2.0, that is our data transformation. So it's looking at how do we modernize processes and key elements to digitize our workflow, and they're having great success with that. And then also I'm looking at what is the emerging technologies that we can take advantage of 5 to 10 years out. We already know some of the technologies, emerging technologies we could take advantage of today, like AI, ML, even things in new networking, 5G. Well, in 10 years, 6G will be in place. And is that going to allow you to create even more immersive and interactive applications and capabilities? Keep in mind, we're still at the beginning of a lot of things. And so if you think about collaboration, which the tools were in place because of COVID, were advanced, but think about, the future. Is holograms going to be the way that we interact? Is it going to be a hybrid workforce going forward? What are the tools they're going to need? So you look at, what better collaboration tools, that's only going to get better. We know what the limitations are today. We know that companies are investing in tomorrow so that the experience is better. But think about if you have workers on lab, in our case, and working from remote, how do they have equal footing? if you will, in terms of being visible, having that water cooler experience, things like that. Those are things that we're going to have to solve, and technology plays a role, as well as human behavior and culture and things of that nature. One more thing, though, compute is going to get much broader and much more capable. You've already seen it in IoT devices, and of course, you're going to see that more advanced in the healthcare sector, thanks to telehealth and things like that COVID has pushed advanced for us. But if you think about, the impacts of computing in the future, you think about quantum computing. Is it going to have an impact in what normalized computing will have, or is it going to solve just specific problems? There's storage of data. We're thinking we have a lot of data today. What are we going to have in 5 to 10 years? It's going to be quite incredible. How do you manage that? So we're looking at the technologies that will be emerging then, as well as networking, as well as storage. So we're at the beginning of this, and but if you go back 5 years, we were at the beginning also. Look at all the things that have changed since then.
Yeah.
And driven. We couldn't. Every company figured out a way to work remote.
Yep.
Some companies went overnight and were able to do that. You couldn't do that as well 5 years ago. So what are the next 5 years going to bring? And what are the technologies, whether it's digital twins, whether it's robotic process automation's already in play today, but is that going to get to be intelligent robotic process automation? Intelligent assistants today, I predict in 5-10 years, we'll have intelligent digital executives, such that they make decisions that otherwise would be made by humans. So
wow.
There's a lot of things to consider with that. I know policy, I know things will fall into play because of that, but technology is not going to slow down. It's going to keep moving forward. And our job is to position JPL to take advantage of the things that help it do its job better for the missions that we do for NASA and the country.
Fantastic. Well, this is all so interesting and so insightful. And it's obviously, all of us that watched the landing and have admired and been interested in anything space related can really find a lot of interest and really cool details about how you and your team affected this successful landing. So thank you so much, Jim. And of course, congratulations, a belated congratulations to your team as well, because how exciting.
It's very exciting. And thank you for having me. I appreciate it.
And thank you all so much for watching this episode of Today in Tech. If you liked this video, be sure to give it a thumbs up and subscribe to our channel. You can hit the bell icon in the corner so you're notified every single time we post a new video, which is just about every weekday. If you have any questions or comments about Perseverance and Mars 2020, were you watching the landing? Let me know in the comments below. I'm really interested to hear your thoughts. Thanks again for watching, and I'll see you next time.